Hi Nana, good morning. In this lecture, I am going to explain you about Bohr's model of hydrogen atom. Bohr's model of hydrogen atom. This is from the chapter Atoms. Bohr's model of hydrogen atom. According to Rutherford, we know that the positively charged particles are located at the center of the atom. Okay, this is known as nucleus, and all the electrons will revolve around this nucleus at a certain distance from this nucleus. Okay. So this atomic structure is just similar to the sun planet system, right? But for planetary system, the force which helps the sun planetary system stable is gravitational force, right? Gravitational force. But for this atomic system, the force which helps the electrons and this nucleus bonded is nothing but Coulomb's force. Coulomb's force. The force between the charges is known as Coulomb's force. For a stable planetary system, the force between the planets and the sun acts is gravitational force, and for this atomic system, that is a nucleus electron system, the force between this nucleus and the electrons is Coulombic force. So what is happening here? The electrons are revolving continuously in the circular orbit around this nucleus. But when the object which moves in a circular orbit will constantly accelerated, you know that. So for a uniform circular path, the acceleration remains constant. We know that the acceleration remains constant. So for a system or for an object which revolves uniformly in the circular path, the acceleration remains constant. Here the electrons are revolving in the circular path around this nucleus. They are accelerated continuously towards the nucleus. That means these electrons are spiraling towards the nucleus and they will fall into this nucleus. Okay, therefore this system is not a stable system. Bohr, from his experiment, scientist named Bohr, from his experiments, he found that the electrons which are revolving around this nucleus in their respective orbits will emit a line spectrum. Okay, but as the electrons spiral into this nucleus, what is happening? The energy of these electrons continuously decrease. So therefore this electron falls into this nucleus. We know that as we move away from the nucleus, the energy of the orbits increases. The energy of each orbit increases. But as we move towards the nucleus, the energy of each orbit decreases. Right? So as the electron is continuously spiraling into this nucleus, the energy decreases continuously. Therefore, the energy which is emitted by these electrons must be a continuous spectrum. But according to Bohr, from his experiments he found out that the electrons which are moving or accelerating towards this nucleus is emitting line spectrum. Okay. So Rutherford failed in explaining the spectral energies of the electrons which is accelerated towards the nucleus. But according to Bohr, the energy or the emission energy we observed is a line spectrum. Okay. But here what is happening? According to Rutherford, the electron is continuously accelerated towards the nucleus and the energy decreases continuously, therefore the spectrum obtained is continuous spectrum. But there is a difference in Rutherford experiments and Bohr experiments. What is this difference? Okay, and why he found that the energy which is emitted is line spectrum, and Rutherford, according to Rutherford, the energy emitted is continuous spectrum. What is the difference? I will explain. To know the difference between the Rutherford atomic model and Bohr's model, first of all you have to know about the energy which is given by Einstein, which is nothing but E equals to mv square also equals to h nu. E is also equal to h nu. Okay. If these are the energy levels of an atom, if this is the ground state, I am taking it as E naught, first excited state, second excited state. Okay. If the electron is in second excited state, okay, and I have given some energy which is h nu to this electron, what happens? This electron will absorb h nu energy and moves to the higher energy state. Okay, and it moves to the higher energy state. Therefore, whenever this electron excites to the ground state or to the higher energy levels, this electron will emit the frequency of certain energy. Okay, so this Bohr observed this spectrum which is emitted or observed, here the emitted spectrum, you will have both emitted and observed spectrum. Okay, there are two types of spectrum. The spectrum is due to emission of energy and due to absorption of energy. Whenever this electron emits energy, you will have emission spectrum, and whenever this electron absorbs energy, you will have absorption spectrum. Okay, there you will find out the line spectrum. So to know about the line spectrum, you have to know about the Balmer emission or Balmer spectral series. Which I am going to explain you in the later class. In our later class, I will explain you about Balmer spectral series. Okay, which is a line spectrum. The spectrum observed there is a line spectrum. So this Rutherford failed in explaining the spectrum of the atoms. Okay, is it clear? Okay, Nana, bye.